Well, today we're going to take a look at this server rack battery from Orient Power. And this is a 48 volt server rack battery, and as you can tell, it's a bit supersized. Now, server rack batteries are very popular for these DIY off-grid systems that a lot of people are putting in, and I've even seen them going into RVs. You know, people putting more 48 volt systems into RVs with server rack batteries. So I really want to test this one out and see what it can do to power the shop at a minimum, to see if it can run the equipment that we normally would need to run here in the workshop. I want to get it all set up and connected to our inverter and power it up. And while I do that, we'll go over some of these really cool specs and features of this big old battery. Ooh, I think I broke the battery. All right, well, the first thing you'll probably notice is that I'm wheeling this thing around on this hydraulic lift cart. And the reason is because this is a heavy battery. It's 189 pounds, roughly. And it's not easy to lift. So, you know, it takes a couple people if you're gonna actually unbox it and move it around. But a lift cart like this is really handy for this. But yeah, it's a big battery, and it's got 16 of these 230 amp EV cells inside, connected in series. In fact, let's pop the top. I've got the screws off right now so we can take a peek inside. Now, one thing that's nice about this battery is that inside the top lid here is a diagram, a little schematic that shows how everything's hooked up to the BMS and all the balance cables and what the color coding is and where the switch is. So it's a nice little diagram to help you understand what the layout is inside the battery. Now we can see how nicely organized the inside of this battery compartment is. You know, we've got this this cover here that, you know, not only covers up all these little balance cables, it makes it nice and tidy, but they've also got each cell here numbered 1 through 8 and then 9 through 16. So these are all connected in series. You know, it starts here at the negative side, negative positive to negative, positive to negative, positive to negative, all the way up through this side on cell 8, and then it branches over to 9 and continues on all the way to this side here, which is our positive side, and this goes through the circuit breaker and out to the battery terminals. So yeah, very neat and tidy. And these are 230 amp hour cells, and each cell is about 3.4 volts. So if we add all of those up, all 16 of them, you know, we get roughly what, 54 volts or something, which is our nominal 48 volt battery. And we keep that 230 amp hours, that stays the same if you're putting everything in series. So 230 amp hour, 48 volt battery. And if we multiply the 48 volts times the 230 amps, we get roughly 11.7 kilowatts. So yeah, a lot of energy storage here in this battery. Now here in the front of the battery is where the BMS is located down here. And this is a 200 amp PACE BMS. And the part number is actually listed here on that front lid. And it's P16S200A. And I think you can find it on, I think it's pacebms.com is the website. But we can see the negative here. One thing that's really cool about this is that this is a flexible bus bar. So it's got some flex to it, which, you know, if there's any expansion or shifting, you know, the BMS is still gonna maintain a decent connection here between this negative side of the battery bank and the bus bar that goes to the BMS down here. Now on the negative side, we also see there's a bus bar tying the two posts of the battery terminals together, And the same is true on the positive side. We've got our positive cables going down to this, also this flexible bus bar here where the this big circuit breaker is, and positive goes down there, and then the other side of the circuit breaker is bus barred right here to the two battery terminals on the positive side. So yeah, really nice build quality here inside. We can also see all the bolts and everything have these little paint marks on here to indicate that they were marked after being torqued and double checked and all that stuff. Put this lid back on. Slides right in like that. And there's screws on the side here that'll hold this down, and there's some on the back as well. Now if you did plan to rack mount these, they came with these brackets that you can attach with these screws to fit inside your rack. All right, I am gonna go ahead and connect the battery cable to these two terminals here. Now I can take either one of these. I don't need to use the inside one or the outside one. These are both bus barred together. But before I connect anything, I want to make sure that the main breaker is off and that the power to the BMS is off. And I can double check that with my meter and just make sure that, yeah, there's no voltage on the battery. So that's what I want. Now we can go ahead and hook these up. Now one thing that they do give you is this little baggie full of battery goodies, and one of them is a bus bar that you could connect both of these together like that or like that to move the connection point off to the side. Maybe you don't want to block this display, or it just gives you more ways to connect the battery cable. And these are threaded here in the middle and on this end terminal there. So yeah, you can save those for later. And you also get some extra bolts here, and these are M8 battery terminals. So one more thing is they also give you all these little silicone covers for your cables and for the battery terminals that aren't being used. So you just don't want exposed metal there when the system is active. Everything's off. I'm going to go ahead and remove these bolts. Each of these comes with a washer and a lock washer on it. Now I temporarily hooked up this box here. The battery connections from the battery come through here, and then those go into this box here, which has a Victron smart shunt in here, and just a little bus bar for the positive and negative. And that's going to help us just track the energy going in and out of the battery, so we can test to make sure that it's hitting its capacity rating. So the output of that goes from here to the inverter. Take this cover off of this. This inverter is already turned off and everything is disconnected, so I can go ahead and remove these battery terminals. So I'm going to connect the positive and negative battery terminals here. Okay, batteries are connected to the inverter. All right, we've got everything hooked up in terms of the battery cables. Now, on the bottom here, we've got a bunch of communication ports. I'm not going to need those right now, but it does come with a data cable for your RS45A, and we've got RS45B and C for connecting additional batteries in parallel and getting them to communicate. But I'm not going to hook the communication up to the inverter at this point because we're just doing some testing, and I don't care that the inverter knows exactly what's going on with the battery. We've got a CAN bus here. If you're using a Victron system or something else that uses a CAN bus, you've got a port for that. And we've also got this RS-232 port. I think it's an RJ11 cable. It's like a telephone, old telephone cable. And you can use that to connect to a computer. And there's some software you can download if you really want to get into the nitty-gritty settings and totally tweak the BMS. I'm not going to do that, so I won't need to use that either. But yeah, I'm going to not use these right now. Right over here we've got our dry contact. This is essentially a couple little relays inside that allows you to set an external alarm or maybe trigger a generator or something. The first two pins, they will connect when there's a low voltage reading. So if your battery reaches its low voltage cutoff point, then it'll connect that and you can trigger something. The other two will basically make a connection if there's any kind of system fault. So some ways to trigger other things, and the dip switches here are just for identifying multiple batteries in a bank. So in this case, I'm just leaving it at 1, or 0, or this is 1 actually. It says 1, 2, 3, 4. Just the first one is up, which is the 1 position. Now, each battery has to be indexed separately so that the communication knows which battery is communicating, across this protocol to your inverter. So it can support up to 16. So yeah, you can add a lot of these batteries and chain them all together in parallel for a really big battery bank. Got an on-off indicator light and a runtime light, and if there's any fault, there's a little alarm, red light, and you should see it's got 4 little lights, state of charge indicator. We can also see that here in the BMS screen once we power that up. This also has a test button here. Push this little orange button. You'll notice it doesn't go off, and you can't turn it back on, so you have to turn it off and back on to reset it. So typically what I'll do is I'll leave this off, I'll power on the BMS, we'll hit the power button, and then from here the BMS is powered up. We go to the menu, we can see a lot of stuff, but we'll go to analog info, hit the enter button, and here we can see the battery charge voltage is 54.78 right now. Temperature readings for the individual temperature sensors, individual cell voltages. But yeah, each of the 16 cell voltages we can see what they are in millivolts here. So yeah, very handy to be able to see that stuff. This should show me the total state of charge here, which is 97%. Yeah, so this is a 230 amp hour battery, and right now it's showing me that it's sitting at about 229.2 amp hours remaining. So let's fire it up. We've got the BMS running. Now, as soon as we turn this on, it should fire up the inverter. Here we go. Now moving over here to this panel is where we can actually switch the whole shop here from grid power over to inverter power and be powered from that battery. So I'm going to go ahead and do that. It's this switch here. Okay, you can see the lights flicker as they transition. So as we turn things on and off here to add more loads to the battery, we can monitor the power output here. We can also monitor it on the mobile app for the Victron Smart Shunt. All right, well, everything is ready to go here. I've got the Smart Shunt screen up and running here, so it's showing 96% state of charge. And I've synchronized that with the battery here as close as possible, so they're both showing about 96%. Now it's pulling about 10 amps right now, and that's just with lights and a few things plugged into outlets here in the shop. So we're gonna go ahead and start turning some stuff on, and especially some of the larger tools, and see how it handles those loads. Yeah, I'll probably start with a couple of space heaters first, and then we'll start adding some other equipment like air compressor and our chop saw and some other stuff. All right, so we're at about 2,000 watts right now with just the space heater and some other stuff running. All right, let's fire this sucker up. Alright, so with the chop saw and the air compressor and the heater going at the same time, I actually blew the breaker. It's just a 20 amp breaker on that circuit. I can also power stuff in the kitchen, so let's just try to keep turning on some stuff, see if we can draw a bunch of power from this battery. And the refrigerator is on and the lights and everything is connected as well. Okay. Hot water. All right, so this BMS is a 200 amp BMS. So that's 200 amps at 48 volts, which gives you a continuous output of about 9,600 watts. So I'm not sure if I can reach that, but I'm gonna give it a try. We got close with just firing up a few things in the kitchen and a heater here in the shop. I think we got up to like 5,000 watts or so. The only thing I can do is to actually add the hot water heater. So I'll have to draw some hot water down and get the hot water heater to kick on, and we might be able to get close. It says here in the book that yeah, it's 200 amp continuous, and we should get a high current warning at 205 amps, and it should give us a fault, high current cutoff at 230 amps if it's over 5,000 milliseconds, so 5 seconds. So we'll see what happens. Yeah, well, maybe I'll jump in and take a quick shower, and that should kick the hot water heater on, and then I'll make some more coffee or something. I'm all refreshed, just got out of the shower, took the water level down a little bit in the hot water heater. So now what I'm gonna do is we'll get everything coordinated, and I'll fire up the hot water heater so that it's just pulling from the inverter, and then I'll have Melissa turn on the microwave and coffee pot, and that should be pushing us up, and then we'll dial in a little heat gun here in the shop instead of the heater, so I can just slowly start getting it increased and see how close we can get to the max. Here we go with the water heater. All right. Okay, there it goes. We're okay, 5,758 watts, and we're drawing like 114 amps or so. Okay, so we'll look at this number here. Okay, Melissa, go ahead and fire up the coffee pot. Okay, the coffee pots are at 7,300 watts. And microwave? Yep, go ahead. Okay, so We're at... Oh! So about 7,500 watts, and we... What happened? Did we get a fault or what? Okay, well here's an update of what happened. So I did a little research online, and SCP actually is a self-control protector. It acts as like a protector to shut down the system if something's wrong, but it also functions like as a fuse in case of overcurrent protection or whatever. So I tried to reset it a few times by turning off the BMS, shutting everything down, and then powering it back on. Then the light went back on again. Now when it happened, you know, we were drawing a pretty good load from the battery, and we were up to about 152 amps or so, and you know, over 7,000 watts, and it was kind of holding there at about 152 amps, and then the power got cut off, and we got that fault. So yeah, I'm not sure where we sit at this point. If I look up in the troubleshooting guide, it says red LED lighting continuous. Possible cause, battery wrong. And under remedy, it says need to repair. So that's where we're at. I think it broke the battery. All right, well, good news. I was able to reset the fault and the error alarm here by going into the battery BMS status. And there's a section there called record. And I guess it shows you the individual errors and faults that it was throwing. So as soon as I went in there, it reset the alarm light and it went out. And everything seems to be back up and running now. And I went ahead and moved the battery from this inverter behind me, which is our 10K inverter, and connected it over here to this LV6548. It's actually an Orient Power inverter. And I also connected the battery communication cable to it since it was already set up for this battery type, which is a Pylon Tech. What I'm going to do next, since we kind of came up a little short on the max power discharge test, we're going to go ahead and move on and do a capacity test. But first I have to charge it back up, top it back off, and get it to 100%. And then we'll put a little bit of a load on it. We'll monitor the discharge and see if we can get a full discharge capacity test on it, like 230 amp hours is what we're looking for. Well, we got the battery fully charged now, and the BMS is reading 100%. It's showing 100% here, and that its remaining capacity is 236 amp hours. So we'll cut the grid power to it, so there's going to be no more charging. And we've got the Victron Smart Shunt set up here. Went ahead and cleared the history, and we're going to keep our eye on this discharged energy value here while we put a small load on it. And we're just going to let it run for a few hours and see how long it takes. It says here it's going to take about 10 hours. So we'll see you in the morning. All right, we're now down to 3% and 224 amp hours consumed, and that comes to about 11.6 kilowatts so far. Okay, our battery voltage is at 44.6, which is getting close to the 44 volts. All right, I lowered the battery cutoff setting to 42 volts, which is its lowest setting. And we're sitting at 43.7 right now. Oh, there went the inverter. All right, well, our capacity test ended up at 227 amp hours, and that was down below 42 volts when everything just kind of shut down. So now the inverter's in recharge mode, so it's recharging the battery. But yeah, 227 amp hours, not too bad. I hope to just kind of squeeze a little bit more, but that's still pretty good. I did some further testing on the battery, having it plugged into our inverter, just powering some daily loads here in the shop and some other circuits, and it performed just fine over that period of time, about a week or so, and no errors or anything like that. But we weren't pushing it, obviously. I know we came in a little low on our maximum discharge test. I think it was 150 out of 200. I'd hoped to get close to that 200, but it probably has something to do with the types of loads that we were putting on it. But I wanted to give it a kind of a practical test to see, what if we did have a lot of these things running at the same time, how would it perform based on how we would use it. But everything else kind of seemed to work out just fine in terms of the capacity test. We're pretty close to the 230 amp hours. Price-wise, this is listed right now at $2,900 for an 11.7 kilowatt 48 volt battery, and that works out to be about $248 per kilowatt. So yeah, I'm curious if you're interested in this particular battery and how you might use it. Let me know. I hope these test results were helpful for you, and I look forward to hearing what you have to say in the comments. But thanks for watching, and I'll see you in the next one.